So on g of x, we could label this point as negative 4 comma 4. That would get us this point on the inverse at 4, negative 4. Here we have 1, negative 1, negative 1. I'll label that in red. And if you switch those, you would still have negative 1 and negative 1. So I'm not going to rewrite the number, but I'm going to put a blue dot on there. The next point, I have 1 comma 3. So I would have 3 comma 1. And finally, I have 3 comma 2. So I would have 2 comma, oops, that's not 2 comma 3. Now sometimes it's a challenge when you go to connect the dots. You might connect them in the wrong order. This is where, if you think about the second big idea, you know that you're flipping over this diagonal line. Sometimes it's hard for our brain to flip over a diagonal line. So on a test, feel free to cheat. Turn your page halfway so it becomes a horizontal line. Flip it over and then turn your page back. No one will ever notice. But if we do flip this over, this is the way that they would connect. Part 2 of this question says, is the inverse a function? The answer is no. And I'm going to remind you of the vertical line test. In mathematics, there's a nice vertical line. In mathematics, something is a function if every x value has only one y value. And we can check that with something called the vertical line test. If I move a vertical line across, and if at any point I hit more than one point on my graph, then that x value hits 2 y values. So the blue graph right now, where I've drawn that vertical line, is hitting at 2 points. So that's enough for us to say this is not a function. When we want something to be a function, we want it to work in our calculator. And our calculator, when we push enter, gives one answer. On this graph, if you pushed enter, it wouldn't know, should I give you this answer or should I give you that answer? It runs into a bit of a problem. Our red graph is a function because if I go across the red one, I never hit more than one y value. So every x value has only one y value. And that's the vertical line test. State the domain and range. This is also interesting. So on the red one, which is the original one, our domain x values start at negative 4, and the biggest x value looks like it is at, oh, I didn't even label it, 3. And the y values start at minus 1, and the biggest y value goes up to 3. Now, on the blue graph, now my smallest x value is minus 1, and my biggest x value is 4.
Is it the one?
Or, oh no, I've got the biggest y value then. Thank you. Yeah, it goes up to 4 up here. I was just looking to the right. And my range of my blue graph, the smallest y value now is minus 4. And the biggest y value is 3. And I want you to notice that the x's and y's got switched here as well, right? Domain are your x values. Do you see that your x values are the same as your range? And the range were your y values, they became your x values. So domain and range get switched as well in an inverse function. All right, questions for practice you can circle 4 and 9.